you continue to make progress. If you've not finished quite yet, or you need to kind of reflect on some of the ones you maybe just guessed on, you need to come back to, because we're doing this lab tomorrow, so it's kind of nice to have a day to kind of think about what's going on here, okay? So, and as I stated, you have your quest that I handed back yesterday, right? The nomenclature one. Make sure you have that during intervention so we can make sure we knock that out. That's an easy 100 grade just to achieve like a reflection correction time, okay? So in terms of 1 and 2, I think you should be fine with those being double replacement and determining the solubility. This is exactly what we done yesterday. Number 3, what did you guys get for your products? What did you get for your products?
Ammonium hydroxide.
Ammonium hydroxide. So you got one. It was ammonium chloride and
Sodium hydroxide.
Sodium hydroxide?
No. Sodium chloride.
Oh, sorry. No, sorry. The initial reactants, ammonium chloride and sodium hydroxide, yes? Okay, that forms ammonium hydroxide and sodium chloride. So initially you're like, hey, no reaction because hydroxides are all insoluble except for ammonium and alkali metals, so that's why you're putting AQ here. And then NaCl, fluorides are all aqueous, no, really outside of the heavy metals. Sodium chloride is definitely aqueous. So I know right now you're putting no reaction because you're like, hey, those are both aqueous. We didn't make a precipitate. But what we're going to note in our lab tomorrow is any evidence of chemical change means it happened. Like the chemical change happened. So what are the evidences of chemical change that we might be looking for? Heat. Okay, what else? Gas evolution. And how would you know a gas was formed? Okay, you could see it, you could test it with the flaming splint test, or smell it. It's got an odor. So we're going to look for one of those changes potentially just so we could verify if this is a no reaction or a yes reaction. So odor, what else could we look for in a chemical change? Possible color change, that would be unanticipated. What else? Precipitate. What else? Flames. Okay, I'm good with that. Yes. Okay. So there might be some instances where we need to see the reaction before we make our final conclusion. We okay with that? Okay. So number 4. Number 4, copper and silver nitrate. So this is the one I want to do an example of the single replacement with you, and that's going to give you an idea on how to do number 5, hopefully. Okay. So what's copper? Cu. And what was the other thing?
Silver nitrate.
Silver nitrate, right? So what kind of reaction is this again? Single. And who's trying to replace who? And is copper successful in replacing silver? Yes, because it's really active. It's super high on the series compared to silver. So they do a little switch, and as they switch, you make what? Copper what nitrate? Okay, so if I never give you copper, if I don't give you copper's charge by chance, assume that it's 2 because copper most commonly forms a 2 charge. So copper what nitrate? Copper 2 nitrate, so NO3 what? 2. And silver. I think we talked about one like this, you alchemist. Remember, did we talk about making pure silver? Yeah. Okay, so hopefully you get to see this happen, but hopefully you can see the fact you're forming pure silver, which is really cool. It's not pretty like silver from a jewelry store though. It's tainted with other chemicals. So you can't have it. Sorry. Okay. So now we have to do the NIE, right? So our goal is write the BCE. Oh, BCE. What do I need? Silver nitrate and the silver. Okay, so now we have our BCE. We also have to note the what? Solubility, right? So within solubility, we have copper. Legit, just pure copper, right? What state of matter is this? It's a pure solid. It's a metal. So put S next to that. And then nitrates, rule for nitrates is everything is soluble, no exception. So you should be looking at your solubility rules list if you don't have one nearby. I think a partner or somebody should, because you're not guessing those at all. That's provided for you. I want to make sure you know how to use those rules. So they're in the soluble category. So we put what here? AQ for aqueous. And then again, we see nitrates. What's the rule for nitrates? All soluble. So again, we have aqueous. And then pure silver. What is the state of matter? A solid, because it's a solid metal. It's not an ion here. All right, so now I've written my BCE, I've written the solubility. What's the next step? Ionize the what? The ionize, only some of them are going to ionize. We can't ionize them all. Okay, so you're basically saying don't break the polyatomics, but are we ionizing the solids or the aqueouses? The aqueouses. The solids stay solid. Don't touch the solids. Bring them down with us, and that's it. So this one's going to stay as is, and this solid's going to stay as is, and these are going to get broken into their two ions from their aqueous form. So copper solid stays with us, plus what? Give me exactly what you're writing. 2Ag, 1 plus, because that has a 1 plus charge. Plus, good, because that 2 distributes to both ions. That's 2 nitrate and O3 1 minuses yields. What's this break to? Cu 2 plus, because that's copper's charge. It's an ion. This? Good, there's 2, because it's subscript of 2, so it can have 2 whole nitrates, so that's 2 NO3s, 1 minus. And what? 2Ag what?
1 plus.
Is there a 1 plus here? 2Ag what? Solids. We do not make it a charge. It is what it is. If it's a solid, it stays solid. If it's a solid, it stays solid. All right, so who are the spectator ions here? What'd you say, Camille? Why not silver? Right, this is silver what? 1 plus. This is an ion floating in solution. You can't see it. It's just a little bitty ion. And this is a big, like, chunk of metal. That's totally different, so don't be fooled. The plus charge means it's very different than the pure solid, so don't cancel those out. So who are the only spectators? 2 nitrate ions, those are it. So how would I write this NIE, everybody? Cu solid, 2 silver ions, and I'll even put AQ there to indicate that it's a different state if it helps a little bit. What else? Cu2 plus, AQ, thank you, and 2 Ag solids. There you go. So that might help a little bit on number 5 if you need to readdress some of those. If you need to talk in your group for about a minute, you have it. If you need to check over any other NIEs, you can shut it. And again, I need to see the process of the NIE. I don't just get the NIE. I'm hoping that you've processed it, because if I just get the NIE, I can't really help you with the one. Nobody says All right, go ahead and put the NIE lab away, and we're getting ready to start our lab together, okay? You've been provided a printed data sheet just to help with some time. Go ahead and write your name at the top of this sheet. Again, please put your NIE lab away for now, and write your name at the top of this types of reactions sheet. So you'll notice that you have a purpose statement at the top. You need to indicate the purpose statement upon you reading the lab. This lab is in your lab notebook. It's probably about halfway back because we're about halfway through. Look for the lab called types of reactions. Okay? And as you can see, there are 4 reactions, A, B, C, and D. You're going to write the observations in the chart on the left and the reactions on the chart on the right. That means the full BCE. Don't go halvesies like I need full reactants, yield products. states of matter are not necessarily important unless it helps you with the processing of the observation. So I want to show you for one of the reactions how to hold the test tube. I think we know how to do the flaming splint test now from that video. What do? You get a popsicle stick, which is your splint, and then you wet. Catch it on fire, and then you put it in a test tube. That's it. Or put it towards the mouth of the test tube. Don't put it inside the full test tube, because then you could very well suffocate the flame inadvertently. And then I know you know how to use a filter paper and funnel combination. Just make sure you have what you need for that. And I will set up a couple filters around the room, because remember, no solids can go down the sink. Make sure we always filter everything. Do you remember how to filter with the test tube upside down? You hold the test tube upside down, and how do you get stuff out? The wash bottle. Okay, you use the wash bottle. And I will tell you have a reactions quiz tomorrow, so I would study over my foldable, because that's like your predictive test, and then you also can find more things online. I can see if I can put some other help on mine. But what you'll do for step 5, which is like reaction D, you're gonna have a flame, Bunsen burner. How do we light that, or how do we set up the Bunsen burner? Go ahead and talk in your groups first. Talk in your groups. Okay, and come back to me. I hope that you know how to light your Bunsen burner. If not, it's like the 5th lab or something like that in the lab notebook. So the only indication or only piece of information I want to give you here is you're going to heat your Bunsen burner or light your Bunsen burner. You're going to hold your test tube over the Bunsen burner, but you're going to hold it not with a ring stand, but with a test tube holder, right? The little like gold test tube holders, and you're going to hold it there at an angle, not an angle at somebody's face, angled like at the wall or something. And then your splint will be caught on fire by the burning Bunsen burner, and you'll stick it just into like the mouth of the test tube, like right there. Don't stick it all the way down into the powder, because then you'll have to run the test like 15 times. Okay? So I'm going to keep you guys in the groups you are currently in. Okay? I do need to move one set of folks because I only have 7 tables, and I need to spread you guys out some. Okay? So go to the lab station, grab some bubbles. I'll touch the reaction lab. I'm going to move a couple people, so don't get too comfy yet. Let me see, make sure you got the group handled first, because I'm going to move some folks. Ready and fluffy lab notebook? And Ryan, keep over here. I just have the making of your credit table. I think it's just a lot of John. Alright, lab, you're going to need the Bunsen burner for a little bit. So I want you to look over the lab so you can. I'm not even turning the gas on, so there's really no moving just at this point yet. But you may begin. You need to go over the lab and get your purpose first. Alright, do not light the Bunsen burner until I say so, but I do want to make sure it's set up right, so let's go ahead and get that baby set up. I'm leaving 30 seconds. Do not light it yet, just make sure it's set up. Alright, and eyes over here in 3, 2, 1, and alright, I just want to show okay. So I just want to show you how to run the first experiment, because you can read the instructions, but a lot of times people don't understand what it's saying. All you're doing is you're putting your piece of magnesium ribbon, it's this little piece of metal that's inside of a bag, sanitary, and you're holding it in your crucible tongs. Okay, make sure you can go behind your computer, okay? And all you're going to do is you're going to light it on fire. You're going to put it in the flame of the intermittent kind of the Bunsen burner. You're going to watch it, and it's going to scare the crap out of you. You're going to want to drop it. Don't drop it. And then it says, hold over the wax. What does it say to do? Hold over the Bunsen burner, get a burning flame in. Then over a black flash. Your black flash, you're not going to hold this to your hand and like, yeah, I'm going to hold a burning flame over my hand, right? We're not going to do that. We're going to leave it down, and we're just going to hold it like this. Do not drop on the watch glass, because then what does it say? I think it says it. Do not drop it, or it'll break the watch glass. I don't want to break the watch glass. Okay, so literally you're just holding it like an inch above the watch glass. You good? Okay, if you're good to light your Bunsen burner, you may begin. If you don't want to light the Bunsen burner, I'll do that. You can't light it until you stop You guys need an inner blue cone. Let's go. The inner blue cone. Take a monkey. Guys, if I can't trust you to look back at some dang instructions and watch how to learn how to light a Bunsen burner, you're not going to do this stuff. Okay? All you got to do is not be lazy, go back and read, follow the set instructions. It is not that difficult. You guys get better. Hold on, I'm working on something. You guys change your oxygen. Change your oxygen. That's gas. I just yelled at them.
I feel like I'm a competition, but I'll give it a shot. Don't you drop it. Don't drop it. Don't drop it. Okay, now make Alright, Bunsen burners off as soon as you're done with step A, or reaction A, and then you guys can proceed. Sorry, I couldn't hear you there. I mentioned it Yes, do the reactions as you go. Keep your goggles on, sir. NaHCO3, sorry. I'm ready. Okay. So, from the observation you made, which everybody, what was the observation made? Upon reacting. Well, no, what was the observation you physically, literally made in the lab? So, A gas formed. You guys saw a little bubble happen between the white powder. Okay, and I'm intentionally leaving it like this because as it was told you in the lab, there was only one reactant. It was sodium bicarbonate. So what kind of reaction is this? Decomp, right? Because you know that it was the fire underneath that, the fire was combusting. I mean, that's kind of how we had to run the lab. We needed that as a procedural step. But that's not what you're talking about. You're not talking about combustion here. You're talking about the powder decomposing. And what observation did you make with that? I know you said gas evolution. But what observation was made along with gas evolution? We tested for the gas, guys. You did this. You tested for said gas. What happened? Well, what? Tell me the observation made with the phosphocyst. Okay, so all of us we were like, oh, waiting for like some cool reaction. We were waiting for it to light back up or for it to make a pop, and you're like, it keeps going out. Let me try again. It keeps going out. Let me try again. So what was the observation you were to make? It goes out, right? So that's the observation. That goes in observation column. So upon extinguishing a flame, you assume the gas is what? Carbon dioxide, because you know all the gas tests now from what, 2 or 3 days ago we watched that video, so you know it's making carbon dioxide as one of your products. So in your groups, talk first, make sure you know what the other products are, what you assume maybe even based on other observations. And you probably saw something else potentially on the sides of the test tube. Think about what you saw on the sides of the test tube. Alright, back group, let it be stuck. Come on. Alright, Kendall's table, what did you guys see on the side of the test tube?
Oh, yeah,
When you say precipitate, are you talking about like precipitation, like rain? So what substance is that? What liquid? What substance is clear? And H2O, thank you. So you guys are beating around the bush about it. Okay, so we know the gases that's made is carbon dioxide because we did the extinguishing test. Who all saw condensation form on the side of the test tube? Maybe you weren't looking for it, so you're like, oh, let me do this flame testing first, but this is definitely water. So what's left that must be a third product?
Sodium.
So we know sodium must be involved, but pure sodium, like pure potassium from the other day, is very reactive with water. It kabooms, it makes big loud noises and fire. So pure sodium's not going to be our final product. Sodium what? Potentially what?
Sodium oxide.
Sodium oxide, right? Because we see some carbons and we see some oxygens. We're probably going to make a very stable product that's a white powder. You probably don't know this, but a lot of sodium powders compounds are white. And so we're going to make sodium oxide, which formula is what? Na2O, because sodium is a 1+, oxide is a 1 or 2- crisscross. All right, make sure all your reactions are balanced. I'm expecting that lab is in the box in about 5 minutes or less. Grab your laptop upon me turning out loud. Yeah, that's what you guys pursue the questions 10 minutes ago.
better than water.
Is it liquid or copper sulfate for number 2?
No, you can just add it to it.
What happened to the liquid?
You could.
This is water too. What do you say?